All right, let's take a look at the exam format. We're going to have a bunch of questions where we've got a model in the form of something like this. Let's call it A minus C times P for quantity demanded. Quantity supplied equals, not C, B. A minus B times P, and then C plus D times P. So I could call this A plus B, and then just remember that B is negative. But I'm just going to do it in this form. I could have said that was A minus C, and then this was B plus D. And then A and B are the intercepts, and C and D would be the slope terms. It really doesn't matter. At the end of the day, the symbols themselves are arbitrary. We want some sort of structure, though, right? There are many ways to get to the same place. You think of it, how do you get from, 1st and 5th in Manhattan? How do you get to 20th and 6th? You can go backwards and forwards and up and down in any number of ways and still get to the same place. Likewise with this. So, things we're going to be interested in: our equilibrium price, our equilibrium quantity, our price as a function of tax, our quantity as a function of tax, and then we'll also think about what we might get if we restrict the quantity or require some sort of quantity. And then we'll also be thinking about dead weight losses. Likewise, to quantity restrictions, we can also think about price restrictions. So let's start by thinking about a before tax price and then an after tax price, which is just P plus T. So P plus T, and then down here is P. I'm just setting that up initially because I'm going to solve this once. And I just set T equal to 0 to find where is our no tax equilibrium. But I've also solved it for where is our equilibrium with tax. Or I put in a negative tax and I've got the solution for when there's a subsidy. So in equilibrium, quantity demanded equals quantity supplied, which means A minus B times P plus T equals C plus D times P. Let's go ahead and factor this out. BP minus BT equals C plus DP. Let's move the P over and the C over. So we'll have A minus C minus BT equals BP plus DP, which is the same as P times B plus D, which lets us say P equals this whole thing divided by this thing. A minus C minus BT over B plus D. So there is our equilibrium price. If we plug 0 in for tax, that is our market clearing price without a tax. If we put in a tax of some amount, it's going to give us this price, and then we add that amount to get this price. Now, one thing we want to know still is the quantity. So this is our price as it affects the supplier. So let's plug this into the supply curve, and we'll say Q star equals C plus D times P, which now is this formula. Let's see, can we simplify that? We could at least factor that D across. Let's go ahead and just see what it looks like. C plus dA minus dC minus D times B times T, all of this over B plus D. We could, let's see what that would look like. That would be if we multiplied this term by this term so that we could have the whole thing on the same fraction. We'd have C times B plus D, which would be CB plus DC. BC plus DC, if we substitute that. And then that would let us say DC minus DC. That goes away, so we'd left with BC plus DA minus DBT all over B plus D. All right, I know that's a lot of symbols. Let's go ahead and just draw it out. So like I said, that DC minus DC is 0, so I'm not going to bother writing it in. I'll just have BC plus DA, DCs are taken care of, minus DBT all over B plus D. And that is equal to our equilibrium quantity. If we have a tax of 0, this whole term goes to 0. And so our quantity is B times C plus D times A all over B plus D. Which is just kind of a way of saying all of what's in here affects where our quantity is going to be, all of the numbers that we could plug in for A, B, C, and D. But we don't need to solve it over and over and over again. We solve it in this form, and then we just plug in whatever values of A, B, C, and D we get into here. And then also, of course, T. So there is quantity. We might also want to know for dead weight loss, it's going to be the quantity compared to where the tax is 0. So we're going to have, let's say, the tax is $10. That's going to affect the price. But this quantity function, we don't need to know the price to find the quantity. That information is already embedded through here, right? And we just moved things around to get to this format, but it's the same information. So the question then is, how much does quantity change with this if we have a tax of $100 compared to if we have a tax of 0? In which case, it would be the tax of 0 minus the quantity that we end up with the tax is this quantity minus this quantity, right? So this minus this, we're going to get rid of that BC, we're going to get rid of that DA, and we're going to be left with minus DBT all over B plus D. Cool. So with that quantity, that change in quantity, we can also say our dead weight loss for a tax. So taking some tax level, tax per unit as our input to this function, we can find that the dead weight loss is equal to delta Q times the tax over 2, right? Area of that triangle, which is equal to, find myself a little bit of space here, dBT times T. So dBT squared all over B plus D all over 2, right? So, or times 1/2 is the same thing, which is the same as saying dBT squared all over 2 times B plus D. Right? It gives us the same result. So now we've got dead weight loss solved in general. We've got the change in quantity. We've got the quantity itself. And we've got the price, the relevant price. So let's go ahead and take this and switch to Excel. See what we've got. Let's see, you don't need to see me. And we can zoom in here. And now we're just going to be translating what we've got here. Oops, that's not what I want. So we've got A, B, C, D, whatever those values are. So A is the top of our demand curve. Let's just plug in 100. B is our slope, so let's just say that's -1, right? Since we're subtracting 1 in the math that I've done here, that'll be fine. C is our price intercept for supply. So when do they start producing at all? Let's say, let's just say 0, just to make things easy. And then D is the slope, and we'll say that's also 1. So we've got slopes that are both 1, -1 for demand. Our supply curve, we're saying, hits the origin, hits that 0, 0 point, and our demand curve hits at 0, 100. So with this, and then we can say, what is the tax? We'll start with 0. And we can say, what price do we expect to get? Or actually, let's start with what quantity do we expect to get? And let's move this where we can see it. Our quantity is, why is this not showing up nicely? All right, I'll try and be relatively quick while I'm doing this. So it's going to be B2, it's going to be in parentheses, B2 plus D2 times A2, ooh, and actually, sorry, B2 times C2, plus B times C plus D times A minus D times B times the tax, which we're holding in E2. Let's go ahead and make that visible. So 2 because we're in the second row. That is the top part of what we've got over here. Now we just divide by B plus D. B2 plus D2. And there's our formula. Our price is going to be equal to C. Well, actually, let's do it. Do we want to do it that way? Yeah, we'll do it this way. Price equals C plus D times A minus C minus B times the tax all over B plus D. Let's see that formula. C, we've got C plus D times a bunch of stuff. That stuff we're multiplying is A minus C minus B times T all over B plus D. Perfect. All right, let's see what numbers we actually get. We're getting a quantity of 50 and a price of 50, and that makes sense geometrically. If we're going from 100 up here with a slope of -1, we're going down to 100 on the quantity axis at a price of 0 for the demand curve. So we just have a triangle with the same base as its height. And then here we're going up at a 45-degree angle. That +1 means one more quantity for one more dollar. So we're hitting right in the middle there at 50-50. That makes a lot of sense. Now if we throw in a tax, let's say we throw in a tax of 10, that means we're putting a $10 gap in here. And again, with this nice even symmetrical slopes of these, we're pushing the price up by $5 for the buyer and down by $5 for the seller. Cool, so we've got most of that. Let's go ahead and throw in the dead weight loss. Actually, let's start with the change in quantity, which is minus stuff over something else. So let's go minus parentheses D times B times E, where the tax is, all over B plus D, minus 5 units, which is exactly what we got. 50 was our equilibrium without the tax. Our equilibrium with the tax is 45. So our change in Q is 5. Let's make these all visible now. So we've got, here's our formula for DQ, here's our formula for price, for quantity, and then we can find out what is our dead weight loss with the tax, and it's just going to be that change in quantity times the level of the tax divided by 2, minus 25. So we got a $10 height. We lost 5 units. 10 times 5 is 50, but it's a triangle, so half of the area of the rectangle around that triangle means a dead weight loss of $25. All right, that gets us through a lot of what we need to think about. So if you've got this much, it's going to be really easy to answer all sorts of questions involving a tax. We could throw in a subsidy. So with a subsidy of, say, minus 20 plugged into the tax, we're still getting a dead weight loss, but notice now we're buying 10 units more than before. Our price has gone from $50 up to $60. So buyers are essentially getting $10 covered, sellers are getting $10 covered. So we're just moving up to the right in our supply and demand curve. We're getting a big triangle on the other side that is 4 times as big as the triangle we got with a tax of $10. All right, let's stop here.